Okay. By the way, today would have been the 90. Some of you that might have used Google today saw that it would be the um, 99th birthday of El Santo, the guy who pretty much created lucha libre, which is the very fast gymnastic style of wrestling that's very popular down in Mexico, and the the wrestlers wear masks, and to unmask somebody is like the ultimate shame that you can do to them. Anyway, and I also think the early lucha libre looked like, this has nothing to do with what we're, and you don't have any questions over this, but anyway, has absolutely nothing to do with well, a lot of it has to do with mysticism, and the bad guy is, might even be like in one of the movies. I mean, the El Santo made all these movies where he would, wrestle a wolf man, or wrestle a zombie, or wrestle a vampire and subdue them, and save the world type thing. Anyway, it's just very creative stuff, and very athletic. If you watch the thing, a lot of gymnastics and a lot of tumbling. Anyway, totally unrelated to what we're doing here. Here we go. Let's look at energy. All right. So now we're going to look at how energy works. So I don't like to go to the entire. Well, let's go ahead and do it this way. All right, so let's look at the energy. It comes in two forms. There's kinetic energy of motion, all right, and the potential energy. Today's lesson is strictly on the kinetic energy of motion, all right, on the kinetic energy. Now, this is a funny looking equation. It's 1/2 of the mass of the object times its speed squared, all right? Since you could say the velocity squared, physicists will say the velocity squared, but let's go with speed squared, because direction we're not so concerned about in this class, all right? And v equals the speed of the object. Okay, very good. That's what my boss put. All right, so now, world's fastest man, my boy Usain Bolt, all right, 9.58 seconds. His kinetic energy was what? All right, if he had a mass of 95 kilograms, take 1/2 times 95, and to do the 1/2, you go 0.5, and I'll show you how to do this in a second, and then 10.4 meters per second squared, all right? And so you get his 5,108 joules. That's like, 500 100-watt light bulbs, or 50, sorry, 50 100-watt light bulbs. And on the top end, though, you get this car that goes from 0 to 270 miles an hour in 1.67. 0 to 60 in 1.67 seconds. Can you imagine? 1.67 seconds. All right, what is the car's kinetic energy when it's traveling at top speed? All right, when it's traveling at top speed, that's 270 miles an hour. We do our quick and dirty conversion, multiplied by the 0.447, and that equals 120 meters per second. All right, I'm going to go to, real quick, let's talk about, let's at least start the notes here. All right, notes for lesson 7, and then I will. So you get an idea of how to do, how to plug them into your calculator if this is all new to you. So we know the kinetic energy, kinetic meaning moving, is 1/2 mv squared. So let's look at that Usain Bolt. Let's actually write it out. Okay, so Usain Bolt's mass of UB was 95 kilograms. His speed was 100 meters divided by 9.58 seconds, which I think came out to be 10.4 meters per second. That's his average speed. So his kinetic energy would be 0.5 times 95 times, now, you can either do it 10.4 and then hit that x squared button on your calculator, or if you're nervous of that, you can go 0.5 times 95 times 10.4 twice. Okay? All right, so that's one way to do that. All right, we'll stop this segment here. I don't want these to get too